Welcome to Wales Tech Week 2021. Thank you to our partners. Enjoy the session.
Well, welcome back to this afternoon's session on the Photonics stage here at Wales Tech Week. Glad you could join us, and looking forward to an exciting and quite a packed event this afternoon. We have a number of speakers, so they're relatively short, sharp presentations about the world of photonics. Hopefully you were able to catch this morning's sessions, and from that you'll understand, or certainly have had a flavor of how important the world of photonics is. Hardly any aspect of our lives goes untouched by photonics, whether it's sensing for 3D sensing or 3D face recognition, or areas such as medical technologies for sensing healthcare issues and so on. Then there is probably some form of light that you are using and relying on in your daily lives. So it's been exciting to hear this morning's sessions on photonics. This afternoon we'll be hearing a little bit more about the role that semiconductors play in photonics, and also the applications across a range of areas that are pretty diverse. So really looking forward to that. If there are any questions as we go along, then please type them into the chat, into the Q&A, and I'll pick those up at the end of the session. We'll also be having a panel session later this afternoon where all of the speakers will come together, so we'll have a live discussion on that. So that should be pretty exciting as well. My name's Chris Meadows. I'm chairing this session, and I'm also a director of CSConnected, which is the umbrella organization that represents the compound semiconductor activities that take place here in South Wales. And a large part of that involves components and building of components in compound semiconductors for photonic applications. And Wales has a long history in photonics and also in compound semiconductors, and the two really marry together to bring some exciting technologies to our 21st century world. We'll start the presentations with Pars Mukesh, who's from YOLE Development. YOLE is an industry analyst, or the industry analyst that really focuses on compound semiconductor applications. So I'll hand over to Pars to tell us all about your view of the photonics markets, and in particular laser diodes. Thank you, Pars.
Thank you very much, Chris, for this introduction. Let me just share my screen. Up, sorry, just 1 second, and we get started. I think now it's okay. Okay, so let's start. So again, thank you very much, Chris, for this introduction. And so for the audience, just to represent myself, so my name is Pars Mukesh, and I am Business Unit Manager at the YOLE Development. And today I will be making a presentation entitled Photonic Market Trend, a Focus on Laser Diode. So let's get started. So prior to starting the presentation, I just want you to better understand who we are. So at YOLE Development, so we are a market research and strategy consulting company involved in the semiconductor area through different topics, such as the one presented here: photonic and sensing, semiconductor, memory, computing, power, and wireless. And so basically, the way we provide analysis to the industry and let's say the players that are involved in the semiconductor ecosystem is that we collect information from discussion with key industrial, aggregate those data, and then use our own methodology as presented here in order to provide the type of analysis that I'm just going to present you. So it was just for the methodology aspect. Now let's get started with a short introduction to laser, because in the end, laser are much more complex than what it looks like. And so I will try to, let's say, explain you some basic about laser system and laser diode in order to better understand the presentation here. So let's start with the historical revenue of laser system market as presented on this scheme. So the laser market has strongly grown during the last 40 years from few $1 million to few $1 billion nowadays. And there is still a lot of potential because there are emerging new applications that are being investigated and let's say marketed every day. So here, just that you could have a global vision on what has driven this market. In the 1990s, what has really, let's say, made this market emerge is the datacom and the telecom boom. And then afterwards, there have been several new applications that have started to, let's say, progress. Material processing, such as the development of laser dicing tool. 3D sensing is also a keyword about laser system, and so on. You need also to understand that there are different types of laser systems as presented here. So semiconductor laser, which are using the laser diode as a direct laser source in order to, let's say, make an application. Then you have a second category related to solid state laser, in which the laser diode is used as a gain media. So this is related to DPSSL for a diode pumped solid state laser and fiber laser. And the third and last category main category, I would say, of laser system is related to gaze laser, for which here the gain media is a gases or a plasma that is being used. So for today's presentation, we'll mostly focus on the two first category of a laser system because they are the one using laser diode, integrating laser diode devices. Now that we have discussed about the different type of laser system, it's also good to have a vision about the main types of laser diodes. So the first one is related to edge-emitting lasers, also called EEL, and the second main category is vertical cavity surface emitting laser, also called VCSEL. So to make it short, the main difference that you have between those two types of laser diode device is related to the light features that you are likely to have using one or the other type of laser diode. So EEL are much more providing elliptical and astigmatic optical emission, whereas VCSEL provides symmetrical low divergence optical beam. So this is really of importance to understand because depending on what you are willing to fulfill in terms of feature for a specific application, you will make the choice of one or the other light source. And so here also just for you to understand, lighting in the end, whether this is related to laser diode or LED, are much more complex than it looks like, because in the end, depending on the lighting features, the wavelength, the way you are likely to integrate this lighting source into the system, you will be able to reach different applications. Just to give you a side example, with the COVID-19 pandemic, UV lighting has been more and more on the forefront, let's say, of the market, because in the end, UV light, deep UV light, has the specific feature to be able to break DNA, let's say the DNA of bacteria. And today, UV lighting is used for disinfection purpose. So it was just an example that you could understand that depending on the lighting source, the wavelength, the property of your lighting device, you can reach different applications. And that's why today for laser diode, there is a wide scope of application that can be handled through those kind of laser devices. So that was for the introduction to a laser system. Now let's make a focus on each type of laser diode, and let's get started with edge-emitting laser that we are likely to call EEL in order to simplify this presentation. So what are the main market drivers for EEL? So as mentioned in introduction, everything started with datacom and telecom application. And for EEL, those are being much more used in optical transceivers for telecom application. I will come back later on this presentation on the difference between datacom and telecom application. So that was the, let's say, historical market driver for EEL light source. More recently, those kind of laser diodes have been investigated and implemented into material processing systems, such as the example that I have mentioned, so laser dicing tools, but also laser marking tools. So in the industry, in the manufacturing, let's say, aspects, there is more and more use of laser because of the accuracy that can be provided by this kind of light source, also the efficiency that is much more better than, let's say, other processes. Typically, if you compare a process using blade dicing and laser dicing, you will have a much more higher quality using laser dicing. The other, let's say, recent driver for this market was related to display and laser-based projection systems. So typically the one that can be used for offices, but there is also an increasing trend of, let's say, using those laser projection display for cinema application. In the future, at short, middle term, 3D sensing should be the main market driver for EEL, with the implementation into LIDARs related to ADAS and automotive industry, or 3D cameras for 3D sensing future. Here also, I will come back on it later in order to give you more details. And finally, another growth driver that could, let's say, happen in the middle to long term, will be related to medical application, typically surgery, laser-based surgery, such as eye surgery. So if we convert those market drivers into market revenue, I would say, what you have to understand is that in 2020, age-emitting laser market, so at the laser diode level, represented already a business of $2.9 billion. And the bulk of this revenue was coming from telecom and infrastructure applications, so typically the integration of EEL for optical transceivers. Other key applications to be mentioned are related to display and material processing. And so this overall market size is likely to grow in the 5 years and reach the size of $5.9 billion in 2025, with still optical communication representing the bulk of this market. However, during this period, there might be also some emerging applications that will, let's say, come on the market and related mostly to sensing, medical, or lighting application. Here, just to give you an example for lighting application, I think you have heard about this trend to integrate laser diode to have, let's say, some higher performance headlamp that allow you to see much more far than traditional LED headlamp, I would say. So let's continue with the focus on the VCSEL this time, and we'll follow the same, let's say, structure as for EEL. So starting with the market drivers. So here again, not a surprise, everything started with the optical transceiver application, but here VCSEL are much more used for datacom application. In the early 2010s, VCSEL have found a kind of new killer application out of datacom and telecom application, and that was related to 3D sensing. So at that moment, one of the key product, or let's say first product maybe to be highlighted, was the Kinect from Xbox, which were allowing to recognize gesture recognition. And this is really the purpose of VCSEL for 3D sensing, being able to recognize some face for biometry application, some gesture, and be able to develop totally new application. What has happened then is that in 2017, Apple released their first, let's say, their iPhone 10, and this iPhone 10 was already implementing a facial recognition system using VCSEL. This has really made the starting point for the use of VCSEL for, let's say, high volume application, I would say. In the short to middle term, we expect VCSEL to move also into LIDAR application, but also automotive in-cabin monitoring system. So I don't know if you are aware, but typically in Europe, there is a regulation that will force, if I am right, starting from 2025, OEMs to sell their new car integrating driver monitoring system in order to understand if the driver is tired, if there is drowsiness and so on, and increase, let's say, the safety aspects of automotive. And so those DMS, those driver monitoring system, can use or infrared LED or VCSEL. And so this is one of the trends that we see in the future. And then as a, let's say, fourth growth driver, we see also more and more smart industrial system and smart building using those kind of VCSEL-based systems. Again, converting those market drivers into market revenue give us those figures. So typically in 2020, the VCSEL laser diode market was nearly $1.1 billion. And you can see that the bulk of this revenue was already coming from mobile and consumer application because of the reason I have just mentioned. When you enter the, let's say, smartphone business, rapidly, you can expect some high volume and high revenue that can be generated. And so in 2025, this trend will continue, and we should reach a market size of $2.7 billion, still driven by mobile and consumer, so applications such as facial recognition, but also augmented reality and so on. So as you might have understand, there are plenty of different applications that can use laser diode. In this presentation, I will try to focus on two main categories of application in order to give you more, let's say, granularity on how those markets are evolving in the future. The first one will be related to optical transceiver, and the second one will be related to 3D sensing, which is also one of the key trends in the future. So let's start with optical transceiver. So let's make just a rapid overview about the principle of fiber optic communication. So fiber optic communication, the mean is to, let's say, transfer, convert, convey data from one point to the other point using the datacom and the telecom infrastructure. So typically you have an electric input, electric signal as the input. Then this signal is transmitted and converted into optical signal, then you use some repetitor, and then at the end, let's say you have a receiver that reconvert this electrical output, this electrical signal into this optical signal into electrical signal. And so the role of the transceiver is typically to transmit and receive this information. That's why we call them transceiver, for transmitter and receiver. And those are really key components in the datacom and telecom infrastructure. What is driving the market of, let's say, datacom and telecom is related to the global IP traffic and related growth. And so in our modern world, in our digital world, this global IP traffic is strongly increasing. So here you can see some estimation made by Cisco about how this is growing between 2018 and 2023. So basically, there is a compound annual growth rate of 10%. And today, honestly, I would say that those estimations were maybe a little bit pessimistic. In the end, with the COVID-19 pandemic and the situation we are having, this global IP traffic is growing much more rapidly than what was expected a few years ago. And mostly because of data-centric applications, such as the use of cloud services, industrial automation traffic, what we're going to call Industry 3.0 or Industry 4.0, and video streaming, let's say, means. Also, in the future, we might see also several emerging applications that will increase this global IP traffic, such as augmented reality and virtual reality one. And so, as the traffic is increasing, the use of optical transceiver is also increasing. And so when you take a look at the market size of optical transceiver, it represented a size of nearly $7.7 billion in 2019, and it should reach in 2025 a size of $17.7 billion at a compound annual growth rate of 15%. And here, this is the datacom application that will evolve the most during this period because of what I have just explained, all those recent, let's say, applications that require the need for increase, and more, let's say, data center. So on one side, for sure, we need higher, let's say, volume of optical transceiver on the market, but we also need to, let's say, develop the technology and move to higher speed. And so here you have an example of roadmap for the telecom application, and this trend to go to higher rate, let's say, optical transceiver, typically from 100G to 200, 400, 600, and 800G in the future. And now coming to the topic of interest, so laser diode, one of the questions you should ask yourself is where EEL are being used versus VCSEL. And so to answer this question, VCSEL are much more used in short reach distance and mostly related to datacom and data center application, whereas EEL are much more used in intermediate reach and long reach, let's say, intermediate to long distance communication. And so this is their positioning. So much more related to the telecom, let's say, application. And here another topic that will be discussed today in the session is related to silicon photonic, which is also an emerging trend. And so silicon photonic is much more in this intermediate reach, let's say, application. So silicon photonic based product regarding optical transceiver already exist, and there are several companies that offer products, and there is more and more that are likely to come on the market, as you can see here in this scheme, presenting the technology readiness level of different companies that are involved here. So optical transceiver for silicon photonics is one of the key markets in the future. But there is another market that should, for which you should keep an eye regarding silicon photonics. This is the consumer health market. And I think you have heard about this recent collaboration between Apple and Rockley Photonics. And so basically, the idea behind that is to implement some silicon photonics chip in the wearable market, so typically Apple Watch, and that will allow to, let's say, silicon photonics to go into, let's say, a market that generates tens of millions of products. And so for the purpose of using silicon photonics chip in potentially an Apple Watch is to be able to combine both fitness and healthcare function into the single system. So that was for the future market of silicon photonics. I have finished with optical transceiver. I will continue with the 3D sensing application. And here, just as a starting point, this is a macro view on the 3D camera module revenue. So in 2019, it represented a size of nearly $5 billion, and this is likely to grow to $15 billion in terms of revenue in 2025 at a CAGR of 20%. What you have to understand is that mobile and consumer, as well as automotive, will be the main driver for this market to grow. For sure, other application, category application are also, let's say, of interest, but today I will focus mostly on mobile and consumer and automotive. And so starting with mobile and consumer, what is driving the use of 3D cameras for, let's say, mobile and consumer application and mostly for smartphone application? So this is presented here. The key features that are, let's say, being enabled with those kind of, let's say, system are related to photography, augmented reality, and user face. And regarding user interface, mostly for biometric application. So remember, I've mentioned about the iPhone 10, the iPhone X. It's really of importance in this industry because, as you may know, when Apple, let's say, launch specific features, the overall industry is likely to follow. And that was the case here when they released their facial recognition based system, their facial recognition system based on VCSEL, which work as, let's say, presented here. Typically, you have some infrared light that go onto your face and then come back onto, let's say, the smartphone. And the idea is to map your face and compare it to the, let's say, database in order to say, okay, I will unlock the phone or not. So this is the first application on the front camera, but there are several other applications that are being investigated on the rear camera, so the back of the phone, for other, let's say, features, typically 3D photograph enhancement, has the examples that are presented here, or augmented reality one. Typically, one day, maybe I will be at, let's say, a store. I will take a look at some furniture, asking myself if it will fit in my flat. And so this is presented here. You could use augmented reality to, let's say, have this kind of features of application. The other things that is related to 3D sensing, one of the key applications is about automotive and ADAS, so autonomous driving, and ADAS for automated driving, advanced driving automatic system. So this is really a trend in the automotive field, and this scheme try to, let's say, evaluate what will be the different level of autonomy that car will have in the future. So basically, the idea is to reach different level, feet off, hands off, eyes off for the driver. And so as you can see here, there will be a long time before seeing, let's say, some full autonomous driving system in automotive. But the question is how to make those cars autonomous. And so to do so, we need to use different sensor technologies. The main are presented here: camera, radar, and LIDAR. So all of them should be implemented in the future because they have specific properties, and there will be also a need for redundancy in order to make, let's say, this autonomous vehicle a reality in the future. And so coming back to LIDAR, for which, let's say, there is a strong potential starting from, let's say, level 3, mostly of autonomous, depending on the application, the feature you are likely to target, you will have, let's say, different range associated to the LiDAR. Will it be a short-range LiDAR for, let's say, a short-range application or a long-range LiDAR? And so depending on those, let's say, range, you will also use different type of light source. And so EL are likely to be positioned on mid to high long-range LiDAR, whereas VCSEL should be positioned, again, as for optical transceiver application, on short-range application. So that was, let's say, the presentation related to laser diode. As a conclusion, and just for you to have a global picture on, let's say, laser diode, I have just re-put, let's say, a kind of market trends slide for you to have a vision on how much revenue we can expect from laser diode, EL, and VCSEL. And so we are likely to move from a market size of $4 billion in 2020 to $8.5 billion in 2025. And so the bulk of the market will still be in the end of age-emitting laser. And so the trends and the application will be related to what I have just presented you. So thank you very much for your attention. I hope you will enjoy the rest of this Wells Tech Week. And so if you have any questions, don't hesitate to ask them during, let's say, the panel, or you have also my address email if you want to ask any other question. And from that, I will give back, let's say, the microphone to Chris.
Thank you, Paz. Very insightful, and some really exciting markets there coming up. And actually very timely, because as Paz said, Paz will be around in the panel session a little later this afternoon, but feel free to type any questions you may have into the chat box, and we'll either pick them up directly from the chat box or refer them to the panel session a little later. At this point, we're moving from the global markets, so Paz gave a very good overview of what's happening globally with some specific optoelectronic or photonic application areas. I'd like to now pass over to our next speaker, Michael Whale. And Michael is very much tapped into the European position, so we'll give an overview of the European market for compound semiconductors and photonic devices. So thank you, Michael.
Well, thank you very much, Chris, and good afternoon, everyone. Giorgio, can you share my screen, please? Oh, thank you very much. Yes, it's my pleasure this afternoon to present some information about how the European programs in photonics are working, and a little bit about how British companies and companies, of course, attending the show today can get involved and take advantage of these funding opportunities. Okay, so as many of you will probably know, the European Union has organized its research activity in what's called framework programs, which typically run for the entire duration of a multi-annual financial framework, which is 7 years. So these have been running since 1984. The last one, Horizon 2020, has in fact just finished. Or in fact, some of the projects are still running. In fact, some of the projects have only just started. But you know, we're now moving on from that financial framework to the next one, which is called Horizon Europe, which will run from 2021 to 2027. Now, Photonics did quite well in Horizon 2020. There was about 700 million euro devoted to photonics, and Horizon Europe actually has an even larger budget overall, though the structure of it is a little bit different, as I'll come to a little bit later. The work programs for Horizon Europe are starting to emerge now. In fact, some calls have already been launched. Information is coming out actually on a daily basis. So I'll give you some pointers as to how you can watch out for that information. The good news is that although we have now left the European Union, we are still able to participate in Horizon Europe. We are what's called an associated country. And that gives us almost the same, well, effectively the same participation rights for Horizon Europe programs as those for member states. So we can join projects, we can participate in projects, we can lead projects. We have access to all of the research and innovation funding from Horizon Europe, except for a very few exceptions, which are on a case-by-case basis in some areas that are deemed to be sensitive for security reasons. We can actually participate in and influence the governance of the Horizon Europe programme, and UK experts can participate in the review process for proposals. And actually, I really encourage people to do that, because it's you can gain a lot of insight as to how the funding process works. So the associated country concept is not new. Horizon 2020 had several associated countries, Switzerland, Norway, Israel, so on. We are now one of them. By the way, there's a lot of information on these slides, and don't worry if you want to take some details down but haven't caught it. I'm very happy for these slides to be made available afterwards. So what's new in Horizon Europe? Well, there are some new institutions. The European Innovation Council, which aims to help companies to bring their ideas from lab to real world, including financial opportunities. There are missions such as the fight against cancer, clean transport, plastic-free oceans. There's a new approach to partnerships, and I'll say more about this in a minute. Actually, we're very well placed in photonics, as we have one of the chosen partnerships. And just worth bearing in mind some of the driving forces which for the programme: the Green Deal, digitization, and technological sovereignty. That is to say, not being reliant upon the wider global markets for everything that we need. And those themes will come up time and time again. So the rules are relatively simple to grasp. Of course, there are huge quantities of legal things that you need to, that are there, but there are also people in the UK, national contact points, knowledge transfer network, who can help you to find your way through all of this. But, put simply, collaborative projects must involve 3 independent legal entities, each established in an EU member state or an associated country, and at least one of them must be in a member state. That's relatively easy to achieve. The main types of actions include research and innovation projects, which are actually funded up to 100% of costs, and innovation actions, which tend to be nearer to market, which get up to 70%, except if you're a non-profit, you can still get 100%. So this is what Horizon Europe looks like. As you can see, there's a fair amount of money there. Most of the things that I think we'll be interested in today are in Pillar 2. This is Global Challenges and European Industrial Competitiveness, which includes programs on health, culture, creativity, civil security, particularly digital, industry, and space. And I think this is the cluster which will be of particular interest for many people attending the call today. So let's have a look at some of the key themes in that cluster. In the digital theme, we have artificial intelligence, data and computing. We have photonics and electronics, and that's a dedicated theme within the digital theme. Smart networks and connectivity, robotics, digital economy. 1.56 billion euros allocated to this, and the first calls actually were published last week. So I'll say a little bit more about that later on. But of course, photonics will have a lot to contribute in the industrial destinations, the so-called circular industries, taking into account recycling, reuse, and so on. Resource and energy efficiency, digital and agile manufacturing, very relevant, I think, for the laser and photonics community, and smart and multifunctional materials as well in that area. As I mentioned, photonics is one of the chosen partnerships, and it's really good that we are indeed as a partnership, because that achieves a dedicated budget, guaranteed budget from the European Commission side. It's committed for 7 years. There are commitments on both sides. The private side also has to sign up to invest and to really do a good job with the funds that are made available. Those commitments, however, are not on an individual company basis. So partners in projects don't need to worry about that point. And the Photonics partnership is a partnership between the EC on the one side and the Photonics 21 Association on the other side that represents the industry. So this gets kicked off this week on Wednesday, actually. You're very welcome to join the signing ceremony, and there will be some keynote talks and relevant information presented on that day. The link is there, photonics21.org, and just follow the links, Wednesday morning. So the Photonics PPP will look like this. We have the big trends, the big drivers around the outside. We have the Green Deal, we have competitiveness, we have technological sovereignty, we have digital transformation. And we've structured the PPP to provide applications-oriented programs and themes, health, agriculture and food, digital infrastructure, climate, mobility, manufacturing, safety, security, and defense, which will link into other partnerships and programs within Horizon Europe, and a core program at the center, which will underpin the technology development on which all the other areas will rely. And Photonics 21, the organization that decides the research and innovation agenda and provides the priorities for the work program, has structured itself in the same way. So we have the core work group, which is providing the technology underpinning, and work groups looking at what's needed in all of the application areas, and they will link and forge partnerships with other European programs, for instance, the Innovative Health Initiative, Key Digital Technologies, Zero Emission Road Transport, and so on. And the Photonics 21 Association, which holds the contract with the EC on behalf of the industry, takes its direction from Photonics 21. Now, I really encourage you to join Photonics 21. It's free, it's open, and it's a highly democratic structure which defines what is done in Horizon Europe Photonics. And it's very easy to do, it takes 2 minutes. So just to give you some insight as to some of the things that are coming up very quickly, there are a couple of calls opening now, tomorrow, in fact, in core photonics, and one in manufacturing. There are potentially relevant calls everywhere in all of those application domains where the photonics industry and experts can play. So just coming up immediately, there's a call on advanced optical communication components, opens tomorrow, deadline October, on all of the technology needed to support optical communications in all its forms, in telecom, in datacom, in computer networks, in industry, in free space, and in fiber, industrial internet, and everywhere that communications is required. There's a call on advanced photonic integrated circuits. These are the devices, the analog of the electronic IC, which works with light, that gives you multiple functions integrated onto a single chip of semiconductor or dielectric material. That also opens tomorrow with a budget of 38 million euros. And then just to give a glimpse of some of the things that are being done in partnership with other partnerships within the Horizon Europe program. Here's one on laser-based technologies for green manufacturing to reinforce industry as a leader in agile green manufacturing, improving the agility of industrial production. Production technologies using lasers are an incredible strength for Europe. We have a huge market share, and this program with 26 million euros budget is intended to underpin and enhance that capability. So in short, there are many opportunities for the UK in European programs, photonics and all of its applications. The UK's associated country status allows UK companies and organisations to participate in projects and lead them. Most Horizon Europe programmes are open without restriction. It's a great chance to build high-tech business and partnerships. And lastly, please take the opportunity to join Photonics 21 and help us shape the future of this programme in Horizon Europe. So I'd just like to thank my colleagues at the Knowledge Transfer Network and Photonics 21 for their great work in building collaborations with Europe and for materials I've presented here. We have some contact details at the bottom there if you'd like to follow up. As of course, you're also incredibly welcome to contact me. And I'd like to thank you for listening.
Thank you very much, Michael. Interesting to see so much work and so many funds committed to the photonics story here in Europe. Some pretty impressive numbers there with almost 54 billion euros on Pillar 4. So look forward to seeing the fruition of that. We'll be hearing a little bit later about the Co-Innovate conference and in effect a workshop that will be organised to follow on from today's event. And part of the idea of Co-Innovate is really to bring together potential partners to work on projects. So we'll hear about that a little later. But now I'd like to introduce Wyn Meredith. And this ties in very neatly with what Michael was talking about, with specific reference to optoelectronic communications or photonic communications. So over to you, Wyn. Thanks very much.
Thanks very much, Chris, and thanks very much for inviting me to talk. So I'll just try and share my screen here. Okay. Can you see my screen now? Okay. Okay, thank you very much. I'm just going to cover some of the areas of compound semiconductor research that are associated with photonic devices. First of all, I'm just going to introduce CSC, the Compound Semiconductor Centre. We are a joint venture between IQE PLC, a global supplier of compound semiconductor materials, and Cardiff University. We've been operational since 2016, and our focus is around developing new solutions for compound semiconductor, so-called epitaxial structures. So these are atomically engineered films of compound semiconductor layers, and a compound semiconductor is really a semiconductor, anything that's not pure silicon, which is the normal inference when you think of semiconductors. So materials such as gallium arsenide, indium phosphide, and gallium nitride. We've seen some information from Pars's presentation around the markets for compound semiconductors, which is a great introduction to my presentation. Our primary delivery mechanisms are around collaborative R&D projects, contract material supply for early stage development of novel materials and device structures. And to date, we've secured around about over £80 million worth of R&D programs since 2016. So next, a quick word on our venture capital partner, joint venture partner, IQE. IQE was founded in 1988, currently listed on the London Stock Exchange and the alternative investment market. It's got a market capitalization of about £500 million, 650 staff. It focuses on foundry supply of compound semiconductor epitaxial materials with 10 sites worldwide. And there's an image there of the latest site, which has been under development for the last 3 years at Imperial Park in Newport. So how do compound semiconductors actually figure in communications applications? Well, we've seen a wide range of applications in the YOLE development presentation, which cover a wide range of communications technologies and consumer electronics products. But in terms of how we get there from a compound semiconductor material, it all starts at the atoms level. So if we look at a compound semiconductor material structure, for instance, for a laser, the actual business end of the laser is probably about 50 to 100 atoms thick in terms of the light generation layers. And then it's embedded into something which is of the order of 3 microns thick, considering that a micron is that's 1,000th of a millimeter. Once we take those epitaxial materials into a fabrication facility to process the wafers into actually chip scale devices, we're starting to work at dimensions around the micrometer in terms of the metallization and etch feature structures. And then we singulate process wafers into millimeter scale chips. A typical laser chip is of the order of 0.2 by 0.3 millimeters, and you can see there are varieties of chip layouts before they get integrated into packages and products that you would recognize in either consumer electronics applications or in the network as components in data communications and telecommunications infrastructure. What's the opportunity for these? Well, we've heard from PARS that there are multiple multi-billion-dollar applications for compound semiconductor devices. You can see there that the market opportunity is driven by the demand for bandwidth and network services, which at the moment is exponentially driven towards a zettabyte scale demand. And we can see there that overall ICT spending is at the level of several $1 trillion. So we're starting to see that the growth in these markets is double-digit, 39% growth in terms of the bandwidth requirements. So in 2025, the prediction is that 10 times more information will be created and replicated than created in 2016. And today, the physical capacity for both storage and transmission just does not exist. And so the market for hardware is going to grow at 24% per annum to service these bandwidth requirements. Another interesting factor, if we look at the total of ICT spending in the market growth in terms of new technologies will represent 25% of total ICT spending, which will drive growth to 2x global GDP in terms of total ICT spend. Next slide. So if we look at the research activities across the CSConnected cluster in South Wales, we've got a wide range of activities in different devices that have been highlighted in our past presentation. A lot of activity in terms of vertical cavity surface emitting laser technology, both for facial recognition and for emerging applications like LIDAR and industrial applications like heating and molding, moving from single element devices to dense arrays. A lot of activities in terms of high-speed indium phosphide edge-emitting lasers, or so-called distributed feedback lasers, which are used in long-reach communications. And a lot of activities around emerging technologies, such as silicon photonics for photonic integrated circuits, in terms of development of silicon photonic solutions and also packaging solutions for these new technologies. In terms of the research roadmap, we're looking at translating research activity from a wide range of solutions for data center, passive optical networking, fiber to the home, into very high-speed terabit scale components in the future, and also the new telecommunications technologies that are unlocked by quantum technology and quantum components. So if you can go to the next slide, please. So just a side discussion here in terms of the general buoyancy of the semiconductor market. Semiconductors are very high profile at the moment, mostly because of shortages due to geopolitical issues between supply between US and China. Also, as a result of the lockdown crisis, supply chains have been disrupted in automotive, and this has led to really an understanding that there's a fundamental need for robust semiconductor supply chains globally. And so we're seeing huge investments announced across the world. The US have announced a 50 billion investment in semiconductor manufacturing. The EU has stated that it aims to double domestic semiconductor manufacturing from 9% to 20% over the next 10 years. And we're seeing big investments in Asia, 450 billion into South Korea, 100 billion into Taiwan. So it really is a very buoyant industry picture at the moment. If you move to the next slide, please. So what's the opportunity for the South Wales cluster? So the South Wales cluster is, at the moment, represents 10 partners across the region, stretching from Caldicot through to Swansea. It's a partnership of 2 universities, Cardiff and Swansea University, 6 companies, and clusters going up around Newport, Newport Wafer Fab, and Caldicot. We have Microchip Technologies, SPTS, and IQE, which represents around about 2,100 jobs across the region. The contribution to the economy is about 172 million per annum, and the gross value add per job is about 86k per job, which is around about 2.5 times the Welsh manufacturing average. So it's a very highly productive industry. It's very research intensive. Typically 30% of the employment in the cluster is focused around engineering, research and development. And in summary, it's a gateway to an ecosystem, wider ecosystem in the southwest, where there's around about 8,500 high value add jobs, which potentially could use compound semiconductors in microelectronic and photonic applications, which contributes about 1.6, 1.7 billion to the regional economy in the southwest. So there is a very highly specialized ecosystem for semiconductor communications components in South Wales. The cluster exports about £500 million per annum semiconductor related products. And so there's an absolutely significant opportunity to turn Wales and the southwest into a communications powerhouse and unlock tens of billions of value in the supply chain if we could leverage high value add manufacturing across communications, supply chains and systems. Okay, the final slide. So thank you very much for listening. Any questions, please contact me or go to our website as listed below. Thank you.
And apologies for some of the technical difficulties we had with the platform and the slides there, but we got there, so that was great. Thank you for that. And without further ado, I realise my chairing is lacking a little bit. We're running about 4 or 5 minutes behind, but we can catch up in the panel session. So it's my pleasure now to introduce Sarah Zhang of Costain, and we're going to hear about another application of photonics that's happening right before our very eyes here in South Wales. Thank you, Sarah.
Good afternoon, Sarah Zhang, Principal Software Engineer from Costain. It's my pleasure to talk about some of the digital solutions Costain developed utilizing photonics and 3D sensing in the UK transport sector. First, an overview of the company, then I'd like to show you the sort of projects we worked on in the digital and technology space. Our company is 156 years old with around 3,400 employees. Top 20 UK management consultant. We have a technology hub that is located just outside Bristol, with the capability of developing bespoke software and hardware solutions. Lasers are one of the most important devices in photonics, I think, and the LIDAR detection system is a laser system that determines the width of individual vehicles as they travel underneath a gantry. It is designed and developed by Costain for Dartford Tunnel to automatically detect oversized vehicles whenever one approaches the tunnel. And there are 3 critical parts to the system. The gantry-mounted detector unit, and the gantry-mounted interface unit, and there is the cabinet-mounted roadside controller. The detector unit itself houses sensors and local processing electronics. Numerous of these will be installed across the carriageway, as you can see from this picture here. That depends on the road width being monitored. Each detector unit contains 60 sensors. It's split into 2 banks of 30 of them, refers to as Bank A and B. And there is a level of redundancy that was added to the design to improve the reliability and durability of the system. A single gantry-mounted interface unit serves up to 4 detector units. What that does is to provide power and collect data from the detector units before sending that data back to the roadside controller that was mounted on the roadside. And the roadside controller itself processes that data and uses an algorithm to determine the width of each individual vehicle. And this is then compared against the internal width threshold. In the event of a vehicle greater than that threshold, the roadside controller will generate an overwidth alert and notify the traffic management system at Dartford Tunnel control room so that the overwide vehicle can be stopped and extracted from the carriageway before it reaches the tunnel itself. We installed about 2,000 sensors, taking in total around 40 billion distance reading per day, effectively producing this very dense and continuous 3D point cloud of traffic as they approach the tunnel. The system itself is a critical part of a cluster of digital solutions that had enabled free flow at Dartford Crossing while maintaining that safety standard. Radar is another type of sensors that we worked with. One of the case study for radar is a level crossing alert system for network rail. Meerkat system provides audio and visual indications for railway cross users at unprotected crossings as to whether it's safe to cross the track or not. For those who are not very familiar with the term, unprotected crossing means footpath and bridleways, where it's up to the users to check for approaching trains before crossing the railway. It is very surprising how many of them there are in the UK. And there are a few challenges for this project. First, the sensors and cables on the railway track is off the table, purely because the network rail want to maintain that integrity of the railway track. Second is the system needs to be self-powered because some of these crossings located in remote areas where a permanent power supply simply isn't available. We developed a new wireless solar-powered audio and visual warning system. And this diagram here is a simplified version of the system. And you can see on the left-hand side, a train comes in, get picked up by this radar. This radar is about 800 meters to a kilometer to the crossing itself, depending on the line speed of the track. Once radar picked up an approaching train, the warning will be triggered, and the audio and visual alert will be switched on. There is also another radar on the same side that is looking at the back of the train as the train travels through. The system also handles trains from both directions. If trains from both directions coincide with within certain time frame, the system will continue with that alert while the audio warning will be changed to another train approaching. We also used VR, another type of photonics application, to engage with the end users and clients throughout the project, such as testing the effectiveness of various warning sound and visual indication during the design stage. A VR trial site model based on where the system will be first deployed allowed the site engineers to visualize and to understand the position of the warning module themselves, as well as the radar detectors. In addition, it helped public engagement when that VR was demonstrated in the local station. I think it's just within just one project, there are so many different types of photonics-based applications are used. It just demonstrates the wide range of photonics-based based technology in our lives today. As many of the presenters already pointed out, from telecommunication, to our daily phone, and to the autonomous vehicles. Without it, a lot of these will simply be impossible. Lastly, our highlight of the connected digital roads. We are very proud to deliver the first connected corridor for the UK. Last year, we delivered video analytics for the Highways England, as well as connected digital roads, which brings smart motorway and connected automated vehicle together for the very first time with production vehicle. To make the connected and automated mobility a reality, there are 3 systems that need to work together seamlessly. There's the intelligent transport systems, connected infotainment systems, and advanced driver's assistance systems. What that means is self-brake and lane keeping, which is all becoming a common thing these days. Photonics-based technology is a critical element, I think, for each of these individual systems, as well as the integration of them all, such as infrared cameras and Internet of Things, enabling the smart infrastructure. Camera, radar, and LIDAR are widely used for advanced driving assistance system. In addition, high-speed data communication is the cornerstone for the integration of these 3 systems. Optical fiber network has just shown an astonishing capacity to transmit data. All optical internet underpins the future expansion of connected digital roads by delivering that improvement in speed, latency, and bandwidth. This will be essential for time-critical technologies, just like the autonomous vehicle, that requires rapid communication between vehicles in the network, and allowing more devices to join that network to give the autonomous vehicle a more holistic view of the environment that it's interacting with. In the transport sector, autonomous vehicles and digital infrastructure are undergoing such intense development. I think this is a huge potential market for photonics applications in the sector. And the other thing I has mentioned as well is the data is increasingly valuable to better manage existing assets and predict maintenance to avoid any disruption when it comes to critical infrastructure, whether it's the motorway, the railway, or the water sector. One simple but very important question we always ask ourselves is how to collect that amount of data accurately and effectively. Manchester Airports Group is looking into the feasibility of monitoring and predicting deterioration on airfield pavement using fiber optic sensors. Photonics will continue to improve transport systems of all kinds in the ways that even before the photonics technology was ready and affordable. I think from the basic solar panel to more sophisticated laser and fiber optic sensors, the scope and influence of photonics is staggering. With the advance in the technology itself, as well as photonics device becoming more affordable, I firmly believe the true potential of photonics is yet to come. Thank you very much.
Yes, thanks very much, Sarah. I totally agree. I think we're going to see an awful lot more, and it's amazing how much photonics applications are already in place. So I think when we look back, perhaps in another 10 years' time, we'll see it as a silent revolution that's gradually taken over parts of our lives that we'd never imagined before. So thanks very much for that, Sarah. At this point, I'd like to move over to Howard. Howard Ruprecht is from Rockley Photonics, and Howard today is going to talk about matchmaking, so technology matchmaking. Thanks, Howard.
Hi, Chris, and thank you very much for the introduction. My name's Howard Ruprecht, and I work as a Director of Strategic Development in Europe for Rockley Photonics. Now, let me just share my screen, and hopefully this will work correctly this time. Right, and put it in presentation mode. Okay, so I'm not going to be talking much about Rockley, but I am going to discuss how we can really connect the innovative sensing technologies, in our case, silicon photonics, with applications such as health and wellness, and how creating a technology platform can actually help customers to develop and scale efficiently across multiple applications. So I actually think a good starting point is to understand the different perspectives and the views and the prevailing mindset of people working in the component technology end of things versus the people who focus on systems level applications and markets. So I hope Win and Chris agree with me here as they're component people, but I actually think component people and technologists are fundamentally very, very optimistic. And they really come from this perspective of, look what my technology can do. They want it to be used in as many places as possible. And, people working in this area typically have really great understanding of how to make, photonic sensors or the related manufacturing technology. So Wim was talking about different layers of epitaxy, but these kind of people are not really the expert in making cars, brain scanners, or aeroplanes. But if you look at the other end of the scale on the application side, you've got a different group of people that I would say are equally innovative, but have a different approach. And I would liken it to working with a box of Lego or Meccano, where they're creating wonderful systems from a selection of components that can be used to create something to solve an application need. So these people do know how to make planes, trains, automobiles, etc., but they're not experts on epitaxy or forging steel. And actually, Sarah's presentation from Costain is a really good example of this. You have essentially a system integrator solving a problem by taking available components and building an innovative system. So the challenge we really have here is, how do we connect the latest and greatest components and technologies with the applications that need them? And business is ultimately created when problems find solutions. And if we look at the world of sensors, there are actually many ways to do the same thing. So if we take something like measuring pressure or measuring light, the key is to find where your innovation adds the most value for a given application. So let's say, for instance, I've just invented a pressure sensor that is 1,000 times more accurate than the best pressure sensor on the market. If I go to a car company and show them this, they might say, well, how does that help my tire pressure monitoring system perform better? But essentially there may be little added value in applications where the need is well satisfied. However, I could take that same sensor and it might offer this huge advantage to a medical device manufacturer who can now measure something like a distant heartbeat much more accurately and closely than they could beforehand. So it's really about matching this technological advantage with a real need. And what I would say is, one of the challenges is it's hard for companies to keep up to date with the latest developments. And of course, larger companies do employ technology scouts or experts in fields that are important to them. But for SMEs, it really comes down to the CTO or individual designers to know what's on offer. Now, as a former engineer, at least nowadays people have the internet to search things. It used to be more difficult. But you have to be aware of what's out there and what's available. But I actually believe the harder problem is for the technology developer. And having spent 10 years plus working with tech startups, early discussions always focus on finding the killer application where the technology has most value. So I've seen many, many tech companies with this great innovation, and they're saying, where could this be really useful? So moving on, let's talk about the sensor market and how we would scale in this market. And, you know, I read a recent report that predicted that the overall global sensor market would be $345 billion by 2028. So it's certainly a very, very significant market. But, you know, I'm going to leave it to Pars and YOLE to stare into the crystal ball and make predictions about the future. But one of the things I would say, and it is really a key thing to consider, is that the market is highly fragmented. And there are some very high volume devices. You know, if we think about a MEMS microphone for a mobile phone, there's going to be 1 billion of those sold each year easily. And even in the automotive market, you know, they talk about 70 million cars, I think is the current level of production. But when you divide that by 14 major manufacturers, 60 brands, a plethora of models, and an average of 100 sensors per car, what you end up with is many, many niches. And then if we take something like medical devices, the volumes may be even smaller. So, for instance, something like 5,000 MRI systems are sold every year. That's a pretty small quantity. And, you know, where this creates a challenge is that most sensors, whether they're MEMS, NEMS, or silicon photonics, utilize semiconductor manufacturing techniques to produce the active elements of the sensor. And actually, as a technology, semiconductor manufacturing has this proven ability to be scaled to high volume with the right equipment and the right investment. However, where you have a challenge is creating low to medium volumes and justifying those financially. So, you know, to give you an example of this, in a previous company I worked at, we made squid sensors for MEG scanners. So these are used to monitor brain activity. And the end customer sold about 10 systems per year, and each system had 250 sensors. So on that basis, the total volume was 2,500 sensors. But if we, you know, consider that a typical 200 millimeter wafer can yield 5,000 sensors, assuming a die size of 5 millimeter, then the annual wafer volume is incredibly low. So if you go to TSMC or even Newport Wafer Fab and ask them for 10 wafers per year, they're unlikely to be interested. Yet the end market for the final product for the sensor could be meaningful and viable. Now, in our case, we were working out of an RTO in a development fab where actually the technology had originally been developed. So we were able to deal with the low volume and accommodate that, but it's not always the case. And it also ignores the cost of developing the manufacturing process in the first place that can be very lengthy and expensive. So really, addressing some of these challenges, like others, Rockley has developed and invested a lot of money to build a technology plan that can be utilized for multiple applications. So, you know, a typical technology platform is a body of work that is built up over multiple years to facilitate the design and manufacture of certain types of components. It's normally a significant R&D investment. And what you're trying to do is to create a platform where the building blocks can be customized to create different types of devices. And then what you're trying to do is adapt and customize for those different applications, normally with some kind of product developer kit to support the design process. But what it really means is that the end customer is not starting from scratch. You know, they're coming in where a lot of the groundwork has been done, and they're saying, can you build us a component on this particular platform? And what that also requires is, you know, dedicated fab partners who you work with to develop the manufacturing capabilities and potentially scale for the future volumes. And in our case, you know, we do have qualified and licensed fab partners skilled in manufacturing at different volume levels. And again, going to the low volume side of things, RTOs such as Tyndall or VTT or IMEC, or even university fabs like Southampton or Cardiff may be able to offer low volume production or multi-project wafer runs, that kind of thing. So what our platform can do. To conclude, Rockley has developed a tech platform for silicon photonics. Our immediate focus is really on health and wellness applications, but there are near-term opportunities in medtech that are lower volume but still very attractive. And there's also good growth opportunities in data center, machine vision, LIDAR. And, we also have a joint venture that focuses on optical transceivers, which is another market that YOLE talked about earlier. So, in summary, we believe that the investment in the platform will endure, and it will allow us to grow in multiple sectors where photonics-based technologies have applications. So, on that note, thank you very much, and we hope to be connecting our platform with exciting applications and opportunities and companies in the future. Thank you.
Thank you, Howard. And yes, I think you're absolutely right. It's often not appreciated just how fragmented and complicated some of the supply chains are, and there's actually very little discussion all the way through. So I think. So I think it's actually quite interesting how we manage those supply chains. And in fact, one of the things that we'll come on to is the process that we're going through with the Co-Innovate workshops and the conferences that we have, which is really about linking the far end of the supply chain even to the OEM and the materials producers, because quite often that communication chain is actually quite fragmented. We've got the panel all back with us now. Mark is due to give a talk. Do you mind if we do a little bit of a panel discussion? Then I'll come back to you, Mark, to wrap up.
Of course, no problem at all.
Yep, that's great, thanks. So we'll just take a few minutes. Luckily, we've been answering questions as have come up in the comments, so we don't have much in the way of awkward questions to answer, but just talking about some of the applications that we see in photonics. I'd like to ask the panel, what sort of real challenges do you think there are in the photonics sector in trying to perhaps get the message across to the end users in the supply chain? And it's very useful that we've got Sarah here, who is at one end of the supply chain, and obviously with Win and what Howard has been talking about, we have the other end of the supply chain. So I'd be interested in your views on how we can actually expand on what Howard said and build those links through the supply chains.
I think from the end of the supply chain point of view, when we come to select the right sensors for a specific project, we consider the pros and cons of the different tech. I mean, for LIDAR itself, it is a method of measuring distance by shooting that laser and detecting how much time it takes. So the accuracy of it is really good. But there's the limitation of it when it comes to weather conditions. For us, we had the challenge with one of the system, the LiDAR detection system. And when we were developing it, we didn't see any issues and everything went fine. And a few days after the system was installed, which was gone through an intensive testing process, and we start to having those triggers coming up, and we don't see any oversized vehicles because it's just reported that there is no oversized vehicles, and the alert just wouldn't stop itself. So after some investigation, we realized the issue was the rain. Heavy rain created a spray of it, and then that has triggered a wide range of a vehicle that the system thought, oh, here there is a huge wide vehicle coming through, and that's why it's keep triggering that alert. And I think in terms of the shortcoming of that technology, we were lucky enough that we can use our algorithm to kind of counterpart that limitation. I think it is for us, we would like to have more understanding of the technology and how it works. So it's really interesting from my point of view to see past a kind of presentation with all different types of waves, because the sensors, they come in all different shapes and sizes, and they can cope with different distance and ranges. So to understanding that different, specification, it is really important for selecting the suitable sensor for a specific application. And the technology itself is progressing and evolving in such a speed, so that to get that message through, to make more information available for the end users, from my point of view, will be really, really helpful.
Absolutely. And of course, it's not a problem we'd have here in Wales, because the sun always shines, so no problem for LIDAR whatsoever. Paz, we have a question about edge-emitting lasers in mobile applications. Are there any at the moment, and do you see that becoming a large area? I know 3D sensing can use edge emitters, but mostly at VCSELs, as you said in your presentation.
Yes. So we are seeing, let's say, more and more interest to try implementing those edge-emitting laser for a different function, and most that I have discussed, so on the back of the smartphone for augmented reality. Because again, the idea for augmented reality is to have, let's say, a feature that can take into account your environment. So large distance, I would say, and so theoretically, EEL might have, let's say, an added value here. On the other side, you have to take also into account that there are several players already involved in edge-emitting laser, and that are also trying to push this technology for those kind of features. So today there is real a dynamic, say, some investment toward this kind of application regarding edge-emitting laser. At the moment, honestly, it's quite difficult to understand which would be the winning technology for those, let's say, a rear application, a rear augmented reality, rear 3D sensing application. Yes, there is a real trend to go toward that.
Excellent, thank you very much. I'll ask if there are any comments that any of the other panel would like to make at this stage. And unfortunately, we'll need to cut some of the panel sessions short, so I can return to Mark to finish off.
Yeah, I can make a comment maybe on the trade-off between edge-emitting lasers and surface-emitting lasers. One of the issues of the edge-emitting is that obviously it's higher thresholds for power consumption, so mobile applications is more difficult because of battery life, etc. And the other disadvantage of the edge emitter, though it can generally produce more power, the beam shaping optics that are required are a little bit more complex and probably a little bit more expensive. So the price or the complexity of the packaging may be a little bit more expensive. So it kind of works where there's a trade-off between eye-safe wavelengths versus the power requirements of the device.
Excellent, and a very quick one from Michael on these linkages with the supply chain. Are any of the Horizon Europe programs geared around building supply chains or not building supply chains, improving the comms throughout the supply chains?
There are indeed many activities in this area, and I'd be very happy, if people particular interest in this area, contact me and we can discuss at greater length. There are a number of what you might call community development activities as well, platform developments, to support the availability of pilot lines in specific technologies that that a wide range of companies can use to enter a particular technology, to bring a particular technology into their application. There is a Photonics hub, which will provide a variety of assistance measures for companies wanting to use photonics in their products, ranging from advice through to actual projects, through to access to finance, and so on and so forth. So excellent. There are indeed a number of initiatives in this area, and bringing the technology and the user together is indeed a real theme of the Horizon Europe activity.
Yeah, and to add to what Mike has said there, as a company, from day one, we worked with R&D partners. We are a company that embraces open innovation, so we've worked with leading research groups around Europe. And I would say, without any shadow of doubt, all of those research groups have benefited from Horizon 2020, and before that, going back to FP7 to develop their technologies in the first place. So I think they very much laid the foundation for what we've developed as a company.
Excellent, thank you very much. And that leads in quite neatly to what Mark is going to talk about, and also to Co-Innovate, which is about collaborative innovation. Something that started as an IQE, Open IQE program in open innovation that was supported by the Welsh Government back in 2015. And in many ways, that led to linking a lot of the supply chains. And so there'll be a workshop planned for the 8th of July. You'll be able to find out more about that on the CSConnected.com website. And that's really a follow-on from today's session to see if we can bring some of these practical examples together. And that's very much supported by the Welsh Government. So I'd like to just hand over now to finish off with Mark Lewis, who's going to give us an overview of the Welsh Government perception and aims for open innovation.
Thanks very much,
Mark.
Chris. Yep, Georgia, the slides are up. That's great. Good afternoon, all. My name is Mark Lewis. I'm part of the innovation team in Welsh Government. My role, I'm responsible for supporting and encouraging open innovation, which has just been mentioned, which is great. As a department, our aim is to increase the successful translation of research and innovation into new and improved commercial products, processes, and services. So what I'll be covering today is I'll be touching on how and why the Welsh Government encourages open innovation, some of the background to Co-Innovate and our involvement in it, working with partners, Welsh Government support for R&D and collaborative projects, and also our vision for getting involved in collaborative projects related to photonics going forward. I'll skip through this slide very quickly because I know we've run slightly over time, but the slides, I understand, can be shared later. I'm quite happy for these to be circulated. The benefits to open innovation are fairly well understood and respected, I think. It's just to say that we've got support available through the Welsh Government Innovation Team that can help organisations to practice open innovation, to become more collaborative, to manage those collaborations, and then, you know, support, advice, guidance to actually undertake collaborative R&D projects. So first port of call is, you know, come and chat to us as the Welsh Government Innovation Team, and we can assign people who can help advise you and take you step by step through what support might be available. This is just an example of a number of the large organizations that we've worked with over the last 4 or 5 years, who have all put into practice in one way or another open innovation approaches. As you can see, there's a wide range of kind of large multinational type organizations here. And it just shows, and this is literally just in Wales, you know, the types of organizations who are looking for collaborative partners. Some of them provide great routes to market for technologies, but just as that kind of knowledge exchange really between some of the bigger organizations and the SMEs, supply chains, and the developers of clever technology, it's a good place to start having conversations with you know, larger organizations who could be either contributors to your projects or potentially even end users. And the same goes for academia as well. You know, there isn't a university really that doesn't look for collaborative partners. This is just a bit of history on Co-Innovate with a bit of a timeline going from 2014. And the slide shows some examples of the different activities that have taken place at previous Co-Innovate conferences and workshops. In 2014, the Welsh Government identified an opportunity to encourage open innovation in Wales. So we ran a competition inviting large businesses to tell us how they developed their approaches to adopting open innovation. And we funded a pilot project with 8 large businesses, the likes of IQE, Tata Steel, Wales and West Utilities, and Airbus. And they worked to put in place a more managed and strategic approach to open innovation and collaboration. Towards the end of that pilot, the industry partners were really keen to work with us to deliver Wales's first Open Innovation Conference. And this is where the idea for Co-Innovate was born. And as I say, it's a partnership approach between Welsh Government and industry. First conference was in 2015, took place in Cardiff. I think we had around about 120, 130 attendees. And year on year, each conference has grown in stature. The last one in 2018 attracted around 300 delegates, and it was starting to get good recognition, not just in Wales, but outside of Wales and further afield as well. We had hoped to run our fourth large major conference in 2020, but COVID put paid to those plans. And since then, really, we've been looking at how we can deliver similar activities online, which brings us to what we're talking about today and the workshop on the 8th of July. So we're focusing on more kind of bite-size focused areas, and it's why photonics is the chosen focus area for this period of activity. And we want as many as possible of you joining us today to attend on the 8th of July, where we'll start to explore and develop project ideas in a more interactive session. So why photonics? I think this has been well documented throughout all of the talks this morning and this afternoon. It's a key enabling technology, huge range of market applications, so massive market opportunities. We've got great capability both in Wales, in UK and across Europe, and we should be kind of growing that capability. And we've got a great number of support networks and funding, which again has been touched on some of the other presentations. We've got the Centre for Photonics Expertise, we've got CSConnected that was launched today. We've got the Photonics Leadership Group. So there are good networks and support programs and funding already in place. Governments are looking to invest and fund these things. So it's a good place to be operating. This just shows Welsh Government Innovation Team commitment to supporting and funding collaborative projects. So 39 collaborative projects in total have been funded, involving over 100 project partners. And this has led to £23 million worth of grant investment from us, and matched by 26 million private sector investment. So just under £50 million total project value. Great kind of investment across a range of projects and sectors, a range of technology themes. And it just shows that I think the growth of collaborative projects. Historically, we would have seen most of the applications coming into our team would be single entities where we would fund an R&D project for a business or an academic team. We see more and more now with the picture changing, becoming more collaborative in nature. And I think each one of these projects that we have funded is a good example of open innovation in practice. So this touches on the specific support available through our Welsh Government Innovation Team. I won't go into in too much detail as we're running over, but I think the message really is to get in touch with us if you've got an innovation or R&D project in mind and you're looking for some kind of support. We've got Smart Innovation, which is a team of client-facing people who are industry experienced, engineering or manufacturing backgrounds, and they can give you some advice on kind of best practice approaches to R&D, where there may be suitable support, whether that be funding or networking support. We got the Smart Company, which is the grant scheme for industry, and this funds kind of R&D projects. And then we've got Smart Expertise, which funds and supports in academic or research organization-led projects where they are collaborating with industry, where there's an industry demand for a certain technology development. But yeah, please do contact us for more detail on each of those. This slide, I don't expect anybody to read it, but it shows the range really of support, starting at the left-hand side with innovation vouchers, which are lower value investments around capital equipment to help you achieve your R&D project, or could be bringing in external consultancy support. And that's 50% grant funding. There's support for process innovation projects. So these are well aligned to kind of manufacturing companies who want to improve what they're doing, drive efficiencies. And then moving across to the R&D funding, which I touched on, and we can fund across kind of all TRL levels, right from the feasibility work, which is desk-based research. The intervention rate for that is high because obviously the risks of projects not going ahead or failure at that stage is quite high as well. And then as you move towards kind of prototype development, the intervention rates decrease slightly, but the amounts of funding available increase, the amount of grant increase, and then we can fund right through to exploitation phase. So yeah, if you've got an R&D project in mind, whether it's you know, just yourselves wanting to work alone, or whether you're looking to collaborate with industry or academia, please do get in touch with us. And generally, if there's a good support, a good project in mind, there may well be support that's well aligned. And I think just some closing thoughts, closing points really, and this has been touched on by some of the other presenters as well, is start to align your search for collaborations with your business strategic goals, because then you're not wasting effort around the periphery and just plucking collaborations out of thin air because they seem like the right thing to do. You're actually using collaboration strategically to match your business goals and business development. Utilize the strong networks and support available. That could just be networks around gaining more knowledge around different markets for your technologies, or could be around engaging with the likes of ourselves or Horizon Europe around what funding support might be available for projects. Lots and lots of organizations are seeking collaborators. You just have to look. So I think gone are the days where you struggle to find a front door into organizations. Most large organizations now in particular will have some kind of front door in, and where they're looking for collaborations actively around their innovation and technology needs. So just the final remark really is if you're interested in developing projects and looking for opportunities to get involved in projects, please do attend the workshop that's planned for the 8th of July. And as I said, that's going to be a much more interactive session where we all roll up our sleeves, explore collaborative project opportunities, start to build some ideas around what those projects might look like, and hopefully we'll be forming and developing existing contacts, forming new contacts with a view to collaborative projects. And then we will assign, or I will assign, colleagues from my team to work with those project groups around what support may be available, and that could be through Welsh Government, it could be UK support, or even wider, it could be the Horizon Europe type funding. So yeah, please do come and attend. We'll share details of how to register shortly in the coming days. And that's me done, and back over to Chris. Thank you.
Thank you very much. So just all that remains for me is just to wrap up and give my thanks to everyone involved. Thanks to Denise Powell for organising all the speakers and pulling the agenda together today. Thanks to Wales Tech Week organisers for making it all happen. And big thanks to the speakers who were given very short time slots to get messages across. But I think they were very successful, and I think it's left a very good flavour and taste of what Photonics can offer, and what activities are underway already, and how we can work together through the supply chains. And finally, thanks to everyone for taking the time out to hear what we have to say. So once again, just lots of thanks all round, and look forward to seeing you again at either the event on the 8th. We actually have a cluster day tomorrow, CSConnected cluster day, which is from 10 in the morning. So another 3 sessions similar to today, dedicated to the compound semiconductor cluster. And hopefully we'll be able to share a bit more detail about the event on the 8th as well during tomorrow. So look forward to seeing you again, and thanks for your time. Thank you all. Bye-bye.
Thank you for watching. Rewatch all of our sessions online. Thank you to our partners.